development of surface in terms of sheet metal working. Because as I already introduced you in the class, that this development, the direct application of development of a surface is in sheet metal working. Okay. So we have this direct option in Fusion 360 for sheet metal. Okay. But it's not that you can directly create a sheet metal for of this menu bar. You have certain things that you have to do in solve, then only you can come into the sheet metal. Okay, so let us say, shall we start with something like a cylinder? Okay, so for cylinder, what is the base surface? Circle. So let us start with the circle. Say radius or diameter of the prism or uh, cylinder is 80 mm. The aspect of one major aspect of sheet metal working is that it has to have a cut edge. For a continuous curve, you can always go with extruding it as a single piece, but the problem is it will not be able to expand until you have a cut. Correct? So for that, what we will do is we will create one artificial cut here. Okay. Something like, say, I'm going to draw a line with, say, again, 42 mm at an angle of 0.5 degrees. Okay. And one more line, again, 42 mm at an angle of minus 0.5 degrees. Minus 0.5 doesn't come. Okay. Okay. So, yeah, 359.5. Right? I think 359.5 works. Right? So 359.5 works. So essentially, why I've drawn that line is because I want to trim off this small segment of the circle. It should be a very small segment. That's why I've done that. I'm going to trim. Okay. I'm going to trim off this small section. Okay. After I trim it, I'm going to delete these lines as well. So if you see carefully, there is a small opening here. Okay. So now we have a full circle, not exactly a full circle, a 359-degree arc. I'm going to finish the sketch. Then I'm going to go with the sheet metal, and there's an option called flange. Click on that flange. And okay, now you can see here, it is asking for you to extrude it or pull it. Okay, now I'll come to the sheet metal rule. So before that, let us define the height. Say it is 150 mm. Okay, right. Now have a cylindrical, which is not a with a small gap of opening of 1 degree. Okay. Now, as I mentioned, there is something called as a sheet metal rules. You see here, sheet metal rules. Click on that and you will find that in this design, you use steel 1 mm. Now you want to edit this, you can edit it here. Okay, thickness you can define it here. Say, let me define it as 0.5 mm. Okay, K factor is the stiffness with which the metal can be bent or worked. Now, there are certain aspects of sheet metal working. The bend radius, generally it is taken as the thickness of the plate itself. You cannot bend it beyond or less than that. Okay, so you need to give this bend radius as function of thickness itself. So whatever thickness that you're giving, that is the bend radius it will take. Okay. So remaining things you can just have a look at it. I'm going to save it. So with 0.5, it's going to work with 0.5. Now let us try opening up this development. So for that, you have to go for create flat pattern. So while creating flat pattern, you just have to select the surface. This is how the development of this surface has occurred. Okay. Now, the problem that we have done in class, you remember that one of the section plane cuts through the topmost generator point at an angle of 45 degrees, right? So I'm just going to click on this finish flat pattern. It'll come back to the model. Now, for that, I need to make a section plane, right? So I need to construct a plane and then draw a line, an axis line through which inclined I can draw, or I can make the construction plane. That inclined section plane can be generated. So for that, I can select this surface and create a sketch. So when I select that surface, I can always snap onto any of these entities. That is the reason why I selected this top surface. I'm going to create a construction line. I'm not going to create any, it's a short line because I just want to create one inclined surface, right? Finish sketch. Let us come to the home view. You can see that axis line about which I'm going to make the construction plane. So plane at an angle, I'm going to select this and give 45 degrees. Okay. So just to have a visualization, I'm just going to increase the surface, uh, a bit longer. So front view of this, you can understand how it is going, right? So for front view, let me just little bit. Yeah, great. So front view, you see, this is how the section plane is going to cut your solid. And side view, you can see it is like this. And top view, it's obviously a circle. There's nothing exciting about that. Okay. So now let us divide this, this part into two. So again, I'll go to solid. Under solid, I can split body. So you can select this body. Splitting tool is this plane. Click OK, and then it splits into two parts. Now, if you observe, your flat pattern is showing an exclamatory mark. That means there is some modification that is done in your primary model. So you can always activate it by clicking on this radio button. So you can see it has automatically generated the sectioned surface. Okay. So this is a simple method for your cylinder. Now, what about cone? How to handle cone? Let me name that. Okay, fine. Now let us try doing for a cone. So for cone again, let me start the sketch with the front view, because I'm going to generate a cone with the help of a generator line. Not going to be a circle and then extruding it onto an apex point to have the cone. Now, why this method is used is because in metal, you need to have profile for generating that cone surface. So let me just quickly show you how it is done. Okay. So let me say the radius of this cone base is 50. Okay. That is only for construction, not for real. And height of the cone is say 120. Okay. Now I need to connect this to this center line. It's not a part of the generator. Okay. So if right now you sweep this, it is not going to become any cone or anything. It will generate a cone, but it is not how we go with it. So for that, yeah, you can finish the sketch. I cannot have a single point of apex when it comes to development of cone. The reason is that if you take a sheet metal plate and if you try to make it and bend it into a cone, you will not be able to get that sharp single point because of its stiffness of the material. So we may have to cut it out a little bit. So I'm just going to go back to the sketch itself, clicking the edit sketch. Okay. And let me create a line. I'm going to create a line, say 5 mm away from the top. Okay. And then use the trim option to trim this part off. Okay. So now I have some line here, which doesn't actually go and meet the apex, but it should give you somewhat a cone kind of a structure. So now let me go to sheet metal. Here, I just trimmed off the top corner. That's all. Nothing else I have done. So I'm going to select this. I'm going to make a profile of very small value. Okay, 0.001 distance. I'm going to make a small profile there. Now I'm clicking OK. Now I'll go to surface. I'm going to create a surface there by rotating that line. I'm going to create a surface. So for that, you can use this rotate profile. So profile, you can select this profile, and axis, you can always select the Z axis, right? I can select this Z axis. And again, here again, I'm not going to go with 360 degree. 359 degrees. Profile is selected. Okay. Axis is also selected. Instead of new one side, there is some error. Okay. I think some issue with the profile. Let me check. Revolve axis. Select this axis. Yeah. Yeah. 359 degrees. Now you can see it is cone. Okay. Now this is just a surface. It does not have a thickness. So you need to define the thickness. You can use this option of thicken. Okay. Now, if you closely watch this, it generates a thickness, right? Now, if I give a small thickness, say 0.5 mm again, okay, 0.5, it is going outwards. What if I want it inwards? What should I do? Minus. Okay, so minus, it creates inwards. I'll click OK. So I have my cone generated. Now I have defined the thickness of the cone as well. Now let us go to, sorry, yeah, in thickness, when you give thickness, don't give new body, give join. I repeat, when you add the thickness, don't create new body, create, the operation should be join. Now click OK. Now coming to this thing. Right. Flange is created. Thickness is also there. Let me just see the sheet metal rule. 1 mm. I'm going to change that to 0.5 because I gave 0.5, right? Thickness. Sheet metal rules. Okay. Now let us try opening it up. Yes. Now you can see the cone development is made. Okay, so it all depends on the sheet metal rule that you give and the thickness of the material that you give as in the thicken option. So if you're going to give thicken option with 0.5 mm, then the sheet metal rule also should be kept it to 0.5 mm. And if you're going with 1 mm thickness of the sheet, then your thicken should also be done with 1 mm. But make sure that there is enough turning or bending radius available in your top when you section this top portion, right? So I'll just come back. Yeah, here. If it in each other, when you increase the thickness, it might intersect at some point here. So that if the intersection happens, then it will show an error. That is earlier I because the thickness was the rule was given as 1 mm. I changed it, therefore I could make the change. Now that's to be applied for various arts. So if you want to generate a prism, say a pentagonal prism, try the problem that we have in our notebook itself. Okay, pentagonal prism. I'm going to go with. I'm going to give. Right. Polygon. Yeah. Okay. I'm changing it to polygon, pentagon. You had one of its faces parallel to VP. I have taken the top view. If you have noticed, I have taken the top view. Okay. Now, once I have drawn, I always have the option of, dimensioning it and constraining it. So say the edge length is 50 mm. It's done. Okay. Now, as you know, since it is a closed figure, I will not be able to make the development properly. So what I have to do, I have to cut open a small portion, a small piece of the any one of the corner needs to be cut open. So let me just, take a small portion here and then use the trim command. Oh, sorry. I'll use the trim command to trim off this corner. Okay. And then I'll delete this line as well. Finish sketch. Now come to sheet metal. So sheet metal, what you have to do? You have to create flange. When you click create flange, you can select this and then give the appropriate height, say 120 mm. I didn't fillet these corners. If you remember, I never filleted these corners, but it automatically came because of the sheet metal rule. Now remember that. Always go and check, modify your this thing and check whether the thickness is correct or wrong. I'll just give 1 mm thickness. For example, I'm going to give 1 mm thickness here. Close. So now, if I want to have the developed this thing, select any one of C, select create flat pattern, select one of the flat surfaces, click OK, and you have your development. Let us look at the problem at hand, which is a sectioned one, right? So let me go with the front view, right? And where does the section happen? In the sectioning is happening at around the midpoint of the axis, right? So let me make a construction plane parallel to this plane. If I remember, I gave 60 mm height, 120 mm height for the prism. So I'm giving 60 so that it is a midpoint. Once the midpoint is there, I can use that to create a sketch. What am I going to sketch? I'm going to sketch a axis line about which it is going to be rotated, right? So let me make that as a construction line. Finish sketch. Now construct plane at an angle. Okay. So already that line has been selected by default. Okay, I can give angle 45. Okay. So just to have a perspective of how much of material is getting cut off, I'm just gonna increase the plane dimensions here. Okay. Let us look at the front view. It is cut like this. Top view is like this. Side view is like this. Okay. Sorry. Yeah. So I've sectioned it. Now I've not sectioned it actually. I have to section it. How? Under modify, split body, select the body, select the tool or the plane, click OK. Now automatically the flat pattern has got a, just click on that radio button. It generates the flat pattern. Now how to take this into a drawing? So let me just save this first of all. Any drawing can be made only with the model. So pentagonal prism. I have named it. Now remember, your flat pattern should be active. You see here, I have not clicked the finish flat pattern. So design, draw in that from design. So it is asking me from which this thing. I'll take A3 itself. Okay. Now it is asking for the scale. Let me take 1:1 itself. Okay. Now you can see the bend axis and the sheet metal pattern which is generated after the section. Now what about the solid base view, right? Click on the base view. You can create the base view as well. You want the front view, you can keep front view, then top view. Anyway, it is going to be the same. I mean, it's a pentagon because it is cutting the axis entirely. Okay, then you need to dimension these. What is the angle? What is the height? What is the edge length? All these things can be dimensioned in this itself. Okay, right. So when it comes to pyramid, again, whatever the possibility of having a single apex point does not exist when you work with sheet metal. Therefore, you always go with a truncated one, truncated pyramid. That means you are just removing your top portion. Okay. Now, how to do that? You can always, okay, I'll just, save this and then I'll move to that. Okay. So let me also quickly go to how to do a pyramid as well. Let us create one hexagonal pyramid. With some base edge, say dimension, say 40 mm. Base edge is 40 mm. Okay. How do you generally make the pyramid? By making one offset plane and then again drawing the top point. But here I'm going to create the offset plane. Okay. That, let us say, assume the height of the pyramid is 100 mm. I'm not going to go all the way to 100. I'll reduce some 3 or 4 mm below. So say 97. Okay. Now on that, I'm going to create the next sketch. What is it? I'll again go with polygon. Okay. So that will be very small. It should be considerably small, but at the same time, you should understand there must be filleting curves possible. What is the fillet curve generated for this thing? It is the radius is generally the thickness of the plate. If you're taking 1 mm thickness, the fillet curve should have 1 mm. So if I am going to give 3 mm here, that means 1 mm on this side and 1 mm on this side should be possible, right? Can be possible, right? Okay. One more thing which I had to do is open one of these small corners, right? So let me just open up this corner here by simply drawing a small line. It should not be too big. Please understand, it should not be too big. I'll cut this part, this, finish. Same way, I'll finish I have finished that curve. Now, same way I have to edit this sketch as well. I'll draw a line, a very small line here. Then, okay. Now what you have to do? You have to generate a surface. Okay. Loft. Same. You have the option of loft here. Loft. Okay. You can select this profile. Okay. I think the loft profile might not work. Let me try. I think the order needs to be proper. Now what to do? It's a surface. What do you have to do? Thicken. Thicken with how much? I'm going to select the entire thing for thickness. Okay. Say let me take 1 mm. Shall I take 1 mm? Okay. No, I didn't go for join. Why? because of the simple reason that I didn't create one profile like I did for my cone. I know you are asking for that, but when I drew the cone, I drew a line, then came to the flange, made a very small thin profile of 0.001 mm, and then only I came to the thickening part of it, and then click the join. Okay, so here I don't have that, but if you see here, you have overlapping surface. You see here, that will create an issue. So ideally, you can go outwards. The thickness can be outwards because of for this reason. Okay, so minus instead of minus, I'm going to give +1 so that. Okay, now what? Hmm? Now you're going to go to convert to sheet metal. I'm going to select the source, the entire thing. Okay, I'll select. Think I have to select one face, or let us see. If I now start, no, it is not. Sorry. Okay. Hmm?